In this example, we're asked to find the domain of the rational function 5x plus 4 divided by x squared minus 3x minus 10. Now this is called a rational expression because, like rational numbers, which are really fractions, this rational expression consists of a quotient of the numerator 5x plus 4, which is a polynomial, and the denominator, which is also a polynomial, x squared minus 3x minus 10. Now we think, what values can x take on? Which values can't it take on? Well, just like in a regular fraction, we look for times when the denominator is equal to 0. So in this case, let's take a look and see, when is x squared minus 3x minus 10 equals 0? Well, that looks like a problem from the last section, doesn't it? What we do to solve this particular equation is let's factor it. The factorization is x minus 5, x plus 2 equals 0. And then that tells us that either x is equal to 5 or x is equal to negative 2. Now for our domain, when we talk about a domain of any rational function, with polynomials in particular, we start with all the real numbers and then we figure out what can't it be. And we just figured out that the denominator can't be 0. Will be 0, so therefore x can't be 5, x can't be negative 2. So let's write this whole summarization in set builder notation. Our domain is going to end up being the set of all x's such that, well, x is in the real numbers, it's a real number, and x cannot be equal to 5, and x cannot be equal to negative 2. So the answer to the question, what's the domain of this particular rational function? All real numbers except 5 and negative 2.